Right, good afternoon, good evening, good morning, wherever you come from. So the talk today is about Kaos. And for those of you that don't know me already, I am uniquely qualified to talk about Kaos, because my entire life has been a variation of a chaotic existence, including my recent travels, which this is a photo taken from. I decided, like any software developer should, to ride a motorcycle across the United States. I started with an estimate. 5,000 miles was that estimate. I blew the budget considerably. In the end, it was 6,370 odd miles, and I felt every single one of them, but no more than the moment when I fell off. That mile I felt very close to my heart. Just a little word of warning, if you ever see a sign in Arches National Park that says broken road ahead, they're not kidding. Okay, anyway, let's talk about Kaos. Who am I? First of all, I'm not this guy, although I hope to get to his age. I'm a software philosopher. That's my declared profession. That means I spend an awful lot of time thinking about stuff, writing code, and wondering why we are as mad as we are to have this industry. It's a great, great profession. And I would like to point out that the only difference, everyone's sitting out there and relaxing, and if you brought a beverage, well done, I did say. You're all relaxing there. What you should be thinking about next year is how you get up here, and I'll tell you how to do it. It's very simple. You have to think. You have to think hard about something, anything in software, anything you like. You think about it harder than anyone else has thought about it, then you get to come talk about it. And that's the beauty of this industry, is all you've got to do, all you've got to do is think. There's me. And that's it. So I'm going to talk to you today about something I think about a lot, and I build a lot of stuff around. I'm going to try and get you to build stuff with me. And then what we're going to do is maybe switch to the other microphone, because that's not going to work for me. Where is it? That's there, I got it. Let's try this. 1, 2. 1, 2. Nope, okay, right. Yeah, don't worry about it. It's all right. I'll just stop moving. Okay, yeah, so I exist completely on Twitter, so if anyone does have ideas for talks at any conferences that I end up going to, just ping me on Twitter. It's the best way. I do use email, but it's more a question of I use email like Twitter. I have about 140,000 unread emails in my inbox right now. For the context setting for later on the talk, I am a chaos monkey for Gmail. That's the way I see it anyway. So I would hate for you to send me an email and want to talk to me. It's much better if you ping me on Twitter or LinkedIn. Okay, this is, like I say, I've just come back from riding across the States. It was an absolutely phenomenal thing. I decided what I would do is I'd ride across and I'd give a talk everywhere I stopped. Even if I was in the desert. Even if I was alone in the desert. I would speak for me. And so I did. And it was a great exercise, because I learned a lot of things about Americans. I didn't learn a lot about the actual physical country, but I learned a lot about the culture. It was fascinating. I'm going to bring some of that to this talk as well, I think. I just want to point out my lovely girlfriend Laura, who's sitting there, very supportive. She's heard this talk so many times. I think it's because she's got to sit there, you see. This is the problem. She can't actually get to the door. But yeah, for someone who had ridden, about an hour or two on a motorcycle, to then up the ante to 5 hours, and then another 6 or 7 hours after that, did rather well. So a round of applause, please, for Laura, if you don't mind. Okay. This is my plan next week. I did say I was an agent of chaos, didn't I? Next week, I thought the best way to relax after a 6,370 odd mile motorcycle ride would be to ride a motorcycle to Everest and back again. So I'm doing that next. I would suggest that a chaotic life and chaos engineering in general is doing me rather well at the moment. I can afford to do this sort of crazy stuff. Okay, when it comes to tech, this is what I do at the moment. It's an open source project. I'm going to show it to you a little bit later on. I'm also going to suggest that you don't go and just go and grab it and use it right away. I want you to think about everything else I talk about before you grab the tooling. because the tooling is a tiny part of what I'm going to talk about. But when you're ready for it, that's a good place to end up. It's a free open source toolkit, really, I guess, CLI, frankly, for doing chaos engineering against your systems. Okay, yeah, so I was doing this ride across the States, and I thought, you know what, 14 hours of riding in a day is not enough. What I need to do is challenge myself. So what I'll do is I'll write a book whilst I ride my motorcycle. And that's what I did, and I'm still finishing it off. But that's what you can see, my estimates right up in the top. It's actually in white and black, but still, it's wrong. But there's evidence of just how bad I get my estimates right there. The great thing about this book is it's free. You can go and grab it now. It's just on LeanPub. There's lots of little snippets inside there about chaos engineering, the stuff I'm going to talk about now. But the cool thing is, if you do decide you have ethics, and it's a decision, you could give some money towards it, and all that money goes to a charity, admittedly a US-based charity, but still a very, very good charity called Girls Who Code. So it's a great opportunity to give a little bit of money if you have it. It's the cost of a beer, perhaps. And if you decide you're going to buy the book and donate some money to Girls Who Code, come and ping me at the conference, around the bar somewhere. I'll buy you that beer. It's fine. Not all of you. Okay, so as a software philosopher, I start with why. Whenever I'm looking at anything we do in this industry and any of the confused things we seem to adopt, you have to start with why the heck are we bothering? And I turn this sort of lens on everything I do. I mean, I do sort of microservice-based training where I start with don't do microservices, and then we spend the next 3 days realizing that we might need something that we would not label as microservices, but we still get what we want. So that's the sort of person I am. I like to start with why the heck are we doing this now? And that's got to be something we ask of chaos engineering. And this is my reasoning for it. See, every second and a half, a company in the world loses $2 to downtime. Every second and a half. Doesn't sound like much, does it? I mean, it wouldn't even buy you a beer in the bar. But it's actually a lot of money when you add it up over the seconds of a year. But even that is the problem with that number is that's a big number. It's huge. And that doesn't make sense to us either. Small numbers and big numbers don't make sense. We're human. We like to relate to the money that's being spent. So I'll give you a different number. In the next hour, who here expects to spend, one way or another, $1, approximately? Not the actual dollar, the equivalent of. Yeah, most people, regardless of what you're doing, you'll probably spend $1 in the next hour. Who here expects to spend $100 in the next hour? I'm going to put my hand up because I'm taking you to the bar. Now, who here expects to spend $100,000 in the next hour? Hopefully no one. If you are, come see me, I've got ideas. That yacht's gonna be mine. So the fact is, that is the average cost of downtime to a relatively successful service right now. Any of the systems that we tend to work on, if they get any sort of decent level of customers, the average number is $100,000 an hour if things go down. An hour. It's worse if you're in media. I won't ask you if you're in media, but the number gets scary. It goes into many more figures on that. Okay? So that's what we're fighting against. And we need a tool, a mechanism, a thought process to help us deal with overcoming $100,000 an hour. So when you talk to people after this talk, when you go to the non-technical stakeholders, ask them how much money they want to lose. And that's where my conversations tend to start. How much did you lose last year? Right, we need a process and practice to stop that in its tracks. Okay? And it usually comes back to this little statement. We need to build reliable systems. But what does that really mean? What is reliable in this world? Well, it's certainly not this microphone. What is a reliable system? We kind of know reliability when we experience it. I used to tell a story where if you're a technical person and you get a new router installed in your home in the UK, you tend to do one or two things. Number one, you probably ping somewhere to see if it's working. You ping Google or the BBC. Now, think about that. You trust the reliability of the BBC and Google more than you trust your own router that's sitting there in front of you, giving you observable lights that say it's working. You've trusted someone else's reliable system more than your own judgment in front of you. So that's what we mean when we're usually referring to reliability, is this consistently always there quality. And in a world where you lose a lot of money if it's not there, and I'm talking about the tangible money you lose, I'm not talking about the loss of face in the industry or people deciding that they don't want to use you anymore because they don't trust you anymore. I'm talking about the observable loss immediately to some of these systems. So reliability becomes probably the only characteristic of a system that matters in the future. If you don't have this, you might as well not have anything else. Okay. But what is reliability? Apart from money, what does reliability look like? Again, I'm a software philosopher. I think about it a lot. And I realize that it's kind of about trust and confidence. And I'm both, not just the one or the other. Because I have a way of thinking about those two words as well. You see, trust is usually based upon past experience. If that system is always there, you trust it's going to be there when you next ping it in the next 10 minutes. It's going to be there. You know, BBC is going to be there. By the way, if the BBC goes down, the world of the UK panics. I call the world of the UK, ever since we Brexited, it is a world. Within that micro economy, we have, as soon as this happens, we trust that system is going to be there. If the BBC goes down, we panic. And that's how quick it happens too. Confidence is a belief in the future. I'm confident it's going to be okay. And that's based upon trust too, but they're all based upon this belief in reliability. But they're two different facets of it. And the interesting thing is we establish trust in systems when we sit there and go, well, it hasn't gone down this week. Woo. Well done. That's trust. But then if you ask, what about if it went down tomorrow? What would you do? What is your plan for the future? What is building your confidence in your system? Or is your confidence blind confidence? And it frequently is. It's based on trust, which is not what confidence is about. Okay. And what it turns out is reliability is kind of another phrase really for safety. We believe a system is safe if it's reliable. It's always there for us. We have trust and confidence in it. And you'll see a lot of people who talk about chaos engineering refer to safety. They refer to books by people like Sidney Dekker, who talks about how we lose safety in our systems very quickly. Okay, and it also turns out there's some underpinnings of reliability, and one of them is resilience. Resilience means in the face of a tornado of effects, the system will cope. Doesn't mean it will necessarily get better at them, but it will cope at it. So resilience is that feeling of when we abuse this system, it survives. When it comes to resilience, three things under that. Security, so if it handles exceptional security cases, it survives. Scalability, under huge amounts of load, or very little, it survives. It's quite interesting to me, a lot of systems fail when they don't get a lot of traffic. It's interesting, I've seen it happen. And then there's fault tolerance itself, which is based upon a knowledge about the system that we build. Because there's an awful lot of it we shouldn't trust. The video earlier alluded to it. Production hates you. And knowing that there are other people in the industry that say production's a wonderful place to be. I've never been to that production. Whenever I've gone there, it's usually a lot of people through either theology or blind hope trying with huge courage to keep a system going. So fault tolerance is another quality inside resilience, which relates to reliability. So what's the problem here? This sort of gives us our framework. We know we need reliable systems. We know that that's probably going to be a differentiator, and if you don't have it, you don't win. But there's all those things to worry ourselves: security, scalability, and fault tolerance at the bottom level. And what's the issue? Surely we do these things already. We're already great at these things because systems at the moment seem to be reasonable. Well, as I say, production hates you, and I have to be careful about this. It doesn't just generally hate one. It's not like the British one. Or the Queen's one. More like the Queen's one. It hates you. It knows when you're out on a date. It knows when you want to sleep. It's kind of like a really seedy, horrible Santa Claus. It's trying. It knows your behaviors, and it knows when you're least prepared for everything to die catastrophically. It's also really good at covering its tracks when it has broken. This sounds a bit weird. The thing is, production hates us already, and then we up the ante. We then focus on feature velocity, which hates us. If you want to build a perfectly reliable system, or as close as you can get it physically in the real world, then you can never change it. Unfortunately, as the companies we tend to work for, regardless of their domain, they want the system to change quickly, frequently. And that's one of the biggest enemies of reliability. So we have a problem. This is the problem. Not only does production hate us, and it's going to throw all sorts of conditions at us we can never predict, but also the feature velocity is increasing. If you go to any business and say, do you want to ship less? They usually don't say yes. And that's because the expectations have grown. The customers have changed. Customers these days are expecting perfect reliability and new stuff all the time. And that's the problem. Okay. And I'm going to use a tool to help us explain it. This is Kinevin. I wouldn't dream to even say I'm an expert in this, but I kind of abuse this system to explain why we've created the problem and why we wanted the problem, but at the same time, how we now need to deal with it. So number one, you are not in simple. No one at this conference could possibly convince me they are building simple systems, unless you are paid to create Hello World. And if you are, well done. Then you're probably not creating something simple. The problem is simple's really attractive because it's got best practices down there. I can say, just do this and you'll be better. That's a wonderfully attractive idea, and an awful lot of consultants want to say that. So you're not there, unfortunately. You probably think you're up in complicated. This is your world, where there are good things you could do. There are practices where someone says, do this, you'll probably be better. The system will improve if you do this, we think. That's not bad. The difficulty is, you're not there either. If you're building anything that you would label a distributed system, I used to say, are you doing microservices and cloud native here? But if there's one thing we could do in our industry, stop naming things. We took a wonderful renaissance in data access and persistence technologies, and we named it by what it isn't. That alone should have barred us from ever naming anything again. NoSQL is the one I'm talking about there, if you haven't caught up. Right? Microservices is in that camp. It gets you immediately thinking about the wrong thing, making things small. That's never the point. Anyway, but if you're building anything that is vaguely distributed, if you're going towards the cloud, then believe it or not, you're probably a distributed system already because you're relying on distribution inside that cloud. And you'll have, these days, dozens of external dependencies. In order to keep our speed up, we need to be reusing other people's stuff. No one wants to reinvent the wheel. Well, I say no one. Some companies try, but they usually lose. So we've got a bunch of external dependencies are becoming much higher impact on our systems. That tends to shift us into complex, regardless of what we like or not. And we're definitely in complex when you consider something else. When I talk about a software development system, I'm not talking about just production. I'm talking about everything that surrounds it. The people, the practices, the process, the whole socio-technical nightmare that is software development. I always tend to think of software development a little bit like, if someone had ever advised me what it would be like to have a baby from 0 to 3 months old, if anyone tells you what that's like, you'd never do it. And it's the same with software development. If someone had told me how difficult this really was, I might have found something else to do. But anyway, we end up in this complex world. And the difficulty with complex is we have to figure it out. Better is something we have to learn in complex. And I have worse news for you. you're not there. You see, if you were building anything like a distributed system, cloud native, microservice, give it a label of your own choosing, that evolve really quickly, which was the point of doing them in the first place. If you are that person who phones me up and says, I've got 40 microservices, how do I deploy them all together into production? You know, as a consultant, I've learned not to come with my first answer on that one, which is basically, you don't. Stop now, step away from the system, you're not good enough to do this. We're gonna do something else. That's not how I started. I go, oh, interesting. Why would you want to? Okay. But the point was to deliver continuously into production with as minimal risk as possible so that we can evolve these things quickly. It's the whole point of doing it. That unfortunately shifts us into the chaotic. That means, and it's not a nice place to be, by the way, it's a difficult place to be, because in here we are surprised by what is better. It's new and interesting. You have to invent better in here. You can't just rely on someone else saying we've seen something, it seems to be better. In here, you're almost surprised when it comes along. So wouldn't it be great if we had a discipline that engineered us out of chaos into the merely complex? That's what we've got with chaos engineering. Yes, I can hear you already thinking, chaos engineering as a term is another thing we should never have labeled. Because the moment you say we're going to do chaos engineering to anyone, they suddenly have visions of you running around pulling cables out of stuff. And that's not the point. So that's the first rule of chaos engineering. It's not about breaking things. That wasn't the point. Unfortunately, the Chaos Monkey did a really good PR job of convincing everyone that's what it is. It's not. We're trying to achieve reliability through trust and confidence in systems. Unfortunately, there's a lot of ways that's being eroded. You're probably familiar with the infrastructure erosion. If you've seen Chaos Monkey, you get this. Something that goes around and says, virtual machines can die, so we better make them die more often. Then people won't make stupid design decisions. Well, there's loads of other facets. As I said, production hates us, but when you drill into that, the machines hate you, the networks hate you, even the cloud itself hates you. Such a hate-filled world. That infrastructure is a place of multiple failures, and that's an attack on our reliability. Also our platform. I won't ask anyone who's using Kubernetes, but if you're using one of Kubernetes' competitors, good luck. Kubernetes is doing rather well in the space, and the reason it does well is it's a great platform. It gives us a level of abstraction above the infrastructure that's quite useful. Unfortunately, if you want to destroy reliability, if you want to explore the failure of reliability, why don't you damage Kubernetes a little bit? We've done this recently. I've done this with Amazon. We're looking at EKS, and we're deciding what should we break in Kubernetes to see if Kubernetes can survive. I'll tell you right now, if you're running a Kubernetes cluster, kill the control plane. See what happens next. It's great fun. Applications. We write the code that causes failures. In fact, when you couple with applications with configuration, you are in one of the hotbeds of failure. We are wonderful at creating configurable software, and then we realize that the majority of system failures come from someone using said configuration. And it brings things down. I mean, we can even talk about big systems like S3. S3 went down because of a configuration change. And by the way, I love the phrase that Amazon used before that. S3 can't go down. Murphy's Law states it will. Okay. So yeah, our own code is wonderful at bringing things to its knees. And then there's the biggest cause of failure in systems, which is us. Everything we do around them. We are wonderful engines of destruction when it comes to production. There's a reason that most traditional organizations with operations groups don't want any of us near them, because they believe in it has to be reliable and perfect at all times. But the trick is it can't be, because we're going to change it a lot. And that's what we do. So as we're changing it and working with it, it's us that's causing those attacks on reliability. Okay, so taking Bertrand's quote, which I'm pretty sure is accurate. I'm sure he said this. Which is this idea of, wouldn't it be great if there was a proactive, us actually engaging with something ahead of time, working with a system to increase our trust and confidence by exploring weaknesses in it before our customers do. before that $100,000 tag hits us. It's exactly what we have. That's why it exists. It exists because at this moment we need it. Our systems are sufficiently complex and that the amount of change that's hitting them is increasing that we need something to help us deal with achieving reliability and availability of these systems. That's what Kaos does. Maintains trust and confidence in your system's reliability over time. Okay, it's a deliberate practice. It's the first thing to know about it. It's something that you do a lot more of because you get better at it. Okay, so when someone's doing chaos engineering, the first thing they'll say is, what tool should I pick? And I say, don't pick any tool. Get a bunch of people together, ask them one question. What keeps them up at night that they worry about in terms of the system we've got? What was the last failure they saw? What was the one that makes them go, oh, that must never happen again? Any of those sorts of questions. Start there. It's a thinking exercise. And then what you do is you say, we're going to get better at that happening. We're going to do this more often. It's actually one of those continuous practices. You know, continuous integration, continuous delivery, continuous chaos. We're constantly working with the system because the system's changing. It's no good doing some chaos today and going, everything's fine. Yep, we've signed it all off. We don't need to worry now, because tomorrow it will be different, and potentially very different tomorrow if you're doing things right. So it's something that we do deliberately, we get better at it, we're improving the whole socio-technical system. Okay. And this is a phrase that a friend of mine, Adrian Cockcroft, uses, is we're trying to commoditize disaster recovery. We're trying to take disaster recovery out of the bounds of that thing that we never do. All right, you're probably familiar. I actually asked this question last November. I said, who here has run their disaster recovery program in the last 2 weeks? A few people put their hands up. I was like, great. And I said, keep your hands up if you did it deliberately. Boom. So the only time you exercise your disaster recovery plan is in a disaster. The worst possible time to learn from it. So what we're doing with this is we're saying we're going to run disaster recovery, small versions of disaster recovery, to see how the whole system reacts so that when or if it does happen, we've got this nailed. It's a bit like a fire drill. Now, I don't like the analogy of a fire drill because you've pretty all had fire drills where, frankly, the alarm goes off and everyone goes, it's 11 o'clock on the button. That's not real, is it? And then they all wander out and then they get confused as to where they're supposed to be and they stand in a car park for 30 minutes in the rain. That's not what I'm talking about. I'm talking about a fire drill where you actually learn from it. When you go, we're going to do a fire drill, but you know what? We're not sure how this is going to go. And we're going to see how we have to improve the system on the basis of how badly we do in this fire drill. Okay, so how do we do it? Good news, we can disagree with Einstein. Every great software movement should be able to disagree with Einstein. And I mean disagree with just this phrase. Now, my German is appalling, and I know I have German speakers in the room. So I'm going to roughly translate, and everyone's going to tell me later on the bar I'm wrong. But the idea here, I think, roughly speaking, is that any idiot, I'm pretty sure he didn't say that, any fool, perhaps, can deal with normal or simple. It takes a genius to deal with chaos. Sorry, Einstein, you're wrong. What it takes is a mindset, starts there. It needs a process to follow, some ethics, which is a weird one, but I'll tell you right now, if you don't get the ethics right, it fails almost every time. You can get everything else right. If you get the ethics wrong, forget it. I'm going to give you some practices to use, I'll show you some tools, and there's a minimum bar to the whole game. Let's go. Mindset, number one. This is a great quote, came out a couple of days ago, actually, from Casey. Casey Rosenthal used to be, I think he's head of Chaos or director of Chaos. Either way, it's a cool title. At Netflix. And it works with me a lot. And one of the things that he said is never let an outage go to waste, which to me captured it. When you have an outage on a system, a chaos engineer immediately goes, we can learn from that. We can improve the system. You don't go, ooh, let's never let that happen again. You go, well, actually, why don't we, now that that can happen, why don't I make it happen more often? I'll give you an example. I was listening to a talk by Alexis Richardson of Weave Cloud over in London. And one of the things he said is, sitting there with a developer, and one of his developers suddenly turned around to him and said, I found a button. He goes, well, that's nice. What sort of button? He said, I found a button. If I press this button, it deletes production. And so Alexis, as he tells the story, Alexis is standing there and he's just moving around like this to say, well, don't, when he hears click. Because if there's a button there, we're going to press it. And I'm thinking that gentleman or lady, whoever it was, is definitely a Kaos engineer. Right there. So yeah, if you find a button, you want to press it. And it killed production. And they've learned that it takes them 45 minutes to get the whole system back, which they were very proud of. That was the whole talk. That's what his talk was about. I put my hand up. And Alexis gave me that look that he gives me when he knows I'm about to ask an awkward question. And the question was this: how often do you press that button now? That's Kaos engineering. It's going, we found a problem, we don't just work around it, we then think maybe we should make this happen more often because you know what, we're going to get better at it that way. It's the same thing with continuous delivery, but that's feature velocity. We get better at feature velocity because we're continuously putting things in production because that's painful, so we get better at it, so we do it more often. Kaos is the same thing. We're terrible at dealing with failure. Do you know what, we're going to make failure happen more often so we get better at it. Yeah, so it has this quality of having a pre-mortem to it. We're actually going to know how to deal with these situations before our customers are on the phone. In fact, it's the worst time. When your customer phones you up and says your system's down, you lose. Okay? You should at least know your system's down before they do. That's number one. We're going to talk about the minimum bar of Kaos engineering in a minute, and that's one of them, is that you must never have customers as your observability. Okay, let's give it a process. Now, I use this process mainly because I'm going to tear it apart a little bit. Because it never really works this way. Because the idea is it's a scientific process. The way you do Kaos engineering is supposedly how scientists do science. Now, I know some scientists. I don't know a single one that starts with a hypothesis. They start by prodding the system. It's a poking exercise. Whether it be a theory or whether it be a piece of biology in front of them, they go, huh, that's not supposed to happen. And then they come up with a hypothesis that makes it sound like they were doing science in the first place. And it's fair enough. I don't have a problem. They still get to the science. That's good. So yeah, you could try and form a hypothesis in Kaos engineering, but you probably won't start there. You'll start by going, oh, that's not supposed to happen. And you'll learn from that. You'll probably do it in staging. I wouldn't recommend you do that in production. But you'll go, what happens if we delete this? We think it'll be okay. Okay. No, it wasn't. That's Kaos engineering. That's where it starts. And then you go, my hypothesis is, that's how you translate it into a hypothesis. I'll start by saying, the system will survive if this happens. And then I'll make that happen, and I realize, no, it doesn't. So now we're going to improve the system because that can happen. And we then will make sure that hypothesis holds. And we call that hypothesis the steady state hypothesis. It's a definition of normal. So whatever looks normal to your system, usually measured from the outside in, normality becomes your steady state hypothesis. It will survive and it's got to look a bit like this. And then we're going to go ahead and make things happen in the method of our experiment. And we're going to make sure that hypothesis is retained. It stands. So that's what we're doing. We're running experiments. We're running experimental methods. And we're going, okay, what if this happens? Wow, that steady state's gone. I don't even know what we've got now. That's what we're looking at. That's what we're learning from. Analyzing the results is the learning part. There's a fundamental difference between Kaos engineering and Kaos testing. The testing is single loop learning. You have a strategy, you do a test, it passes or it fails. Kind of binary. Kaos engineering's only close analogy in testing is exploratory testing. Because you're asking open questions. You don't know what's going to happen. You suspect there might be a weakness. You're looking for new knowledge. So that's why we call it experimentation, not testing. Small point, but it's important. Now, this point here is interesting because it says, increase the scope of your experiment, which implies that we started small, and you should. Do not be the person that phoned me up and said, I've just run Chaos Monkey in production. It destroyed everything. I knew it would. That sentence is the one I'm going, you probably don't want to do Kaos engineering, right? You should never do an experiment when you know the answer already. That's not an experiment, that's sadism. And you start small, start tiny, start in staging. You might stay in staging. It's a little-known sort of dirty secret of chaos engineering that just because Netflix kills production on a regular basis doesn't mean you have to. You could do this in staging as long as you can learn from it, as long as you're learning, getting real confidence and trust from your system through these experiments, do it in staging. It's fine. Don't treat production as the blocker. So you start small as well. You don't start with what happens when we delete a region. Instead, or something like that. Yeah, so what you do is you start with, what happens if the database slows down? Or as I love the phrase that you see, if you want to wake up in the morning, delete a table from a production database. That sort of level, start with that. Start with something that you've seen before, start with something real world and go, we think we can cope with this now, let's make it happen, see if we're better. And finally, once you've increased the scope, because you increase the scope to gain more and more confidence, eventually you'll automate the experiments. You don't even start there. You can do this manually tomorrow. You can do this tomorrow. Chaos engineering is something you can do with a bunch of people tomorrow and learn from your system without any tools. But doing it that way, and we'll talk about that in a minute, is expensive on people's time. Whenever we have something that's expensive on people's time and it has to be done continuously, we automate it. Okay, I mentioned how chaos fails. Chaos engineering dies if you don't get this part right. I watched an argument happen on Twitter, which I think is what Twitter's for. It's an argumentation platform. And I watched two people argue, and they were both right. They were both correct. And what I was seeing is that one group was saying to do chaos engineering, you have to have a dedicated chaos engineering group. Sorry. Let's do it this way. That's better anyway. Okay, so one group was saying you need a dedicated chaos engineering group. The other group was saying, we can't afford that, we're startups. And they're both right. What they didn't realize is that there was something in common between these two statements. And that thing in common was the ethics of success in chaos engineering. If you are the person on Friday at 6 p.m. who is inclined to destroy a couple of VMs, to be able to turn around to the teams on Saturday when they come in because they have to, and say, I did that so that we could learn from it, don't do chaos engineering. There's a reason for this as well, because the ethic here is you have to have skin in the game. Regardless of whether you have a separate group or you actually have people inside the teams doing chaos engineering, they will be part of the solution as well as part of the experimentation. They have to be committed to helping you improve as well. Otherwise, they're not chaos engineers, they're chaos sadists. And that will fail, because what will happen is the teams will turn around and go, we don't like the chaos people, they just make our life hard. So get rid of those and throw them away. And you'll fail at it. And I would hate you to do that. So this is number one. Anyone who's creating chaos has to be part of the solution as well. 2 practices in chaos engineering. Number 1, game days. Easily the most fun thing you'll ever do in your life. Now, I might be biased in this regard because it's a bit like doing Dungeons and Dragons. I'm that sort of geek. All right? I used to love being a games master, a dungeon master. I would be sitting there going, I can make up stuff and see how they deal. And it's the same way that Stephen King writes novels. He gets a bunch of characters, puts them in a situation, sees what happens. Possibly why his endings are pretty... Anyway, I don't know. So with game days, it's on a similar level. You get a bunch of people together and you ask them, what are we worried about? And you say, right, we're going to make that happen next week. And we're going to see how we deal. We're going to explore the playbooks. We're going to explore how we understand production. We're going to find that hero in our group and make sure they're not the single source of problems. And that's how I've done it. I've done game days recently. I had a great game day because I realized I was working with a team and they had playbooks for operational failures. And they put them in a room with a door, with a lock and a key. And I could lock that door and pretend the key was lost. And I could see how they would deal with a production failure, or at least as they saw it, a staging one. And I did, and I learned a few things from this. Number 1, stop people before they break a door open. Number two, even if it's in staging, a lot of emotion is involved when there's a failure happening. There's a lot of pride on the line. So that's another reason, as a chaos engineer, you don't just do this for fun, you do it for profit, you do it for make things better. Because if you do it for fun, people are going to consider you to be hurting their pride. But game days are expensive. Doing these like exercises with people are expensive. You can't do them continuously enough. So then we automate them when we can. And we automate them because we want to run these things more frequently. Same as we always do. Okay, a minimum bar. For those of you near the front, probably realize something about me. I'm quite short. And so when I go to a theme park, I'm there with my daughter, who's getting rapidly taller, which worries me. And there's always on those rides, you know, it has a sign next to it in the distance that just says, you must be this tall to ride this ride. And as you walk towards it, the fear begins to set in. Because it gets taller as you get nearer, and you start to go, that day's coming where I have to say, right, Marley, you can go on, Daddy's too small. That's the minimum bar I'm talking about here for chaos engineering. If you're not this tall, you shouldn't be riding the ride. And that's observability. You need to be able to ask open questions about your system, otherwise chaos engineering will just cause you nightmares. The good news is you could use one small aspect of chaos engineering to get you there. I've done this with groups where I've said, we're going to do a game day where something fails in production. I'm not going to tell you what it is, but you're going to need to find it, explore it. We're going to see how this works. And the very first thing I see is developers going, we have no idea what staging or production looks like. We don't know where anything is. We don't know what the passwords are. We don't know where the logs are. Oh yeah, by the way, if you want to get developers to write great logs, do a game day. It's great fun. I've had that asked many times. How do we make developers write good logging? Make them the consumer of those logs. And if you can't do proper DevOps, then do it in a game day as well, because that's where you'll see it. So observability comes from this quantity of being able to ask open questions about the system, because you're going to need to figure things out. So you need to be able to ask, what is there, what's going on, how did it get into production? I'll give you an example. I did a game day where I shipped a bug into production, staging. And I wanted to see if they could find out what had happened. They spent a good few hours rooting around in staging, having no idea what had happened. If they'd had good observability of their pipeline to production, they would have known that Russ had shipped a bug. But they didn't have that observability. They were looking at the output, not the path to the output. Okay, some tips just to leave you off with today. When you go back and start to say to people, we're going to do chaos engineering, the reaction you're going to get is, don't. It happens all the time. I had that with the bank. I was working at a bank and down in Canary Wharf in London, and they said, what are you doing here? I said, I'm doing chaos engineering. And they said, no, you're not. No, we've done that. We had 2008. We're not doing that again. And admittedly, it was a joke at the time, but it was like, no, I am doing chaos engineering. And I realized I couldn't say that to them. And so you shouldn't need to say that to them either, because the first rule of chaos engineering for the business is don't use the term. I'm going to give you a better one. Continuous, limited scope, disaster recovery. It's exactly the same thing. But it gets a budget rather than getting you evicted from the building. Also, don't talk about what you're going to break. Don't go in and go, do you know what we're going to do? We're going to break some VMs. Go in and talk about production incidents. Talk about what's happened. Then people will care. If you also don't do wacky experiments either. That will never work. I had one company where they said we destroyed a region, simulated destruction of a region, but weirdly enough, no one seemed to care. Well, there's a reason for that, because they've never seen it happen before. They believe you've done something crazy, and therefore no one's going to learn from it. Okay, some rules for Chaos Club. Number one, you already know the first rule. No one talks about Chaos Club. So don't use chaos engineering. Continuous, limited scope, disaster recovery for everyone. So don't talk about Chaos Club. Rule number two, it's about learning, not about breaking things. If you already know that a failure is going to happen, and it will cause an outage and an issue in the steady state hypothesis, don't do the experiment. Fix the problem, Then do the experiment and find something surprising. Talking about surprise, chaos should not be a surprise. You should never go up to a team and say, we've done some chaos. Didn't tell you, but we've done it anyway. Because they will not like it. Chaos starts by asking the teams what they're worried about, not what you dream up. And as I say, really just hammering the point. If you already know the answer, don't do the experiment. Okay, in terms of tooling. Okay, tooling-wise. This is a course I give. I have not seen the film. I have not read the book. But I believe it goes something like this. Under significant stress, a system will improve. Is that how the book goes, roughly? So this is what I do. I used to teach microservices. I still do sometimes. And one of the ways I teach it is I say, well, we're going to set up the system, we're going to run through these practices, we're going to do service discovery, we're going to do bulkheads and circuit breakers. And you know what happens? No one listens. No one cares about circuit breakers. So I figured it out. The way to teach people about circuit breakers is to break things. Is to do a little bit of chaos. And that was the last day. The last day on that course is called 50 Shades of Microservices. Because all I do is punish their systems for naivety. And we explore all the non-functionals on that basis. Now, when we worked with AWS, they were not too happy with me calling calling their online resource 50 Shades of Microservices. And so instead we came up with applying chaos engineering, which is more boring, but there you go. So we did this for AWS, and I'm going to show you the tooling that we use to create their chaos for their automated examples. Whoa. Hello. Okay, so this is the place to go and grab this toolkit and have a play with it. All right, this is the stuff we used at Amazon. It's really simple, it's just a CLI. Do not expect anything too dramatic. It works like this. You will ask the Chaos Toolkit to do things to your systems and also to give you outputs from that experiment. So you define an experiment in a format, you give it to the Chaos Toolkit, and then it does it. And it comes back with, this happened. We saw this. You told me your steady state hypothesis was this, it deviated. An experiment in our world is just a JSON description. I apologize briefly for it being JSON. It could be YAML, but I have a real hatred of YAML. I've been burned too many times. But we are looking at a YAML variant. I'm just not going to work on it myself. I did have one person come up to me after a talk and say, I love your toolkit, but I'm never going to use it. I was like, why? I thought it was personal. And it turned out that this particular lady was using, I think she was Danish, and she was using a German keyboard. She had no idea where the curly braces were, and they seemed to move. So fair enough. Yeah, you might not write much JSON in that case. But the idea is you're going to write a JSON document, although there's a quick way of doing that, and you give it to the CLI, and it runs it against the system using a set of drivers. Now, one of the things we knew is we couldn't create all forms of chaos. You're going to have your own variants. So you'll plug in your own variants into drivers as well. They could be as simple as an HTTP call, which you can actually write no code. You could put in a process of your own making. If you've written something in Golang or something less trendy, then it could go in there. And then you can also write it in Python, because that's what the toolkit's written in, and we make no apologies. Okay, when you build an experiment, first thing you do is run discover. Discover is a command. You point at your system and say, figure out what's there. Discover also might suggest experiments based upon what it sees. Then you initialize an experiment. You say, take what I've discovered, build me an experiment. That way you don't have to write so much JSON. And then finally you can run it. And then because we have to work with other people, then we're going to also produce a report at the end. So discover, you point it at something like Kubernetes. You give it the driver you want to use, or list of drivers. It then produces a discovery JSON document that you do not want to read. No one here is going to want to read this thing, unless you're really into JSON. Then you do init. It'll take that discovery document, and it gives you an experiment of your own making that you can then tweak and use. You run your experiment, and this is what I love about this. As a tester, you look at this and go, oh, we've got a problem. As a chaos engineer, you look at this and go, ha, we found something. We've discovered a weakness. It's a good thing. So here we found a weakness in our system. There's a naivety in our system about a particular failure that we're causing. But Kaos is eminently collaborative. You're not going to do it in isolation, ever. So what you do next is you run report to give yourself something that other people might want to read. In this case, we'll produce a nice little PDF that makes you look like you're doing proper science. We're not just destroying stuff, we have a summary. Okay, and I have a summary now, so let you all go to the bar with me. In summary, I have a confession. Earlier on, I said in a complex system, or even a chaotic system, there are no best practices. I'm in the, I think, relatively unique position where chaos engineering is a best practice for exactly these sorts of systems. It's a best practice mindset. But what I would say to you as a caveat on this is if you're going to do chaos engineering, start by doing the hard thing, which is thinking about the system, exploring weaknesses yourselves. You don't need tooling. You don't need any of the other stuff I've talked about here. You just need to start with asking those questions of what are we worried about? And I would also say that one of the big challenges of chaos engineering is it doesn't bode well for training. It's not an easy thing to train people in because your context is so unique. So one of the things you might want to do is come and chat to me about doing workshops and stuff at your place. I refuse to do generic training on this unless it's on the tooling. Tooling's fine, you can teach tooling. But when it comes to the thinking process and everything that goes with it, you have to do it in the world. And that's why Casey and myself and a few others have created something called the Chaos Collective. Sounds a bit elitist, it's not. The idea is that we can actually help people do those workshops and get started and worry about things like the ethics and do things the right way and see if it fits for you. And you'll start with game days because they're cheap, free, easy, and fascinatingly fun. Then you might use the toolkit to automate things for your flavor of chaos that you want to do continuously. And a few next steps for you. Number one, read the Principles of Chaos if you haven't already. Wonderful document. Basically describes everything I've just mentioned. That's why it's wonderful. Once you've read that, you can get the Chaos Engineering book from O'Reilly. It's free. Proper free. And there's one last thing. This is a Build Stuff conference. This is a call out now for you to get involved. We are rapidly building a collection of drivers for all the different forms of chaos that we can encounter out there. And we're looking for anyone who's interested in helping out and getting involved. So we have an incubator that we put these things into. And in there's everything from chaos causing mechanisms against things like Cloud Foundry, or even just probing systems like Prometheus, because when you run an experiment, you need to ask questions about the system as well. So we support Prometheus in there. The weirdest one is Chaos Toolkit Slack, because chaos is collaborative, and we like to put the messages that tell people we're running chaos into Slack as well. So that's all going in there, and we'd love your input, and I'd love your input. And if you catch me over the next half an hour at the bar, we could code some stuff and actually build it, do some chaos. Preferably not against your production system whilst you're at the bar. It's probably going to mean you don't do chaos engineering again. Okay, so come and chat to me about it. This is the company I've got. We're a product company, so we've built the toolkit and we're building stuff on top. But we also do, like, let's say, these Chaos Collective days to help people get started. And that is all I have for you this evening. I hope you've had a wonderful time at this conference. I certainly have. I will apologize on the behalf of the weather for day one, or part of day one. And then I will not apologize at all for the rest of it because it's been fantastic. I've had a great time. I hope you have too. I hope it's been of interest, and I'll see you out on the road. Thank you very much.